So this is the bridge design final project by T. Hobbs, Tinsley Martin, Musco Lemmy, and Sarah White. For the project background, we were tasked to replace an existing 100-year-old bridge over Washington Street in Atlanta, located near the Georgia Dome. Our client for this project is the Georgia Department of Transportation. The site was broken into three sections: north of MLK, ending at the railroad tracks, past the railroad tracks to Decatur Street, and from Decatur Street to Gilmore Street. Section 1 is approximately 600 feet. Section 2 is approximately 450 feet. And Section 3 is around 580 feet. The original bridge was constructed utilizing T-beams. A specific challenge within Section 2 is minimal clearance between the bridge and the surrounding buildings. Multiple buildings have only an inch of space between them and the bridge deck. For the design of the new bridge, we need to consider clearance over the MARTA and CSX rail lines, as well as the existing parking and lower streets. The team also needed to match upper level access, such as parking structures and building doorways. Existing utilities also must be considered when designing the footing of the bridge. This area is highly traveled, therefore GDOT has placed a 180-day max closure for this area. Some strategies and solutions that we have is conventional construction, high early strength concrete, pre-stressed concrete, and girders, steel end diaphragms, and micro piles that allow you to shrink the size of the footing cap. We also are proposing a phased construction package, which allows you to start on the beginning phases of construction.
Here I'll be talking about the bent and footing placement from the plots that we were given. So this plot here shows section 1 and part of section 2, and the next slide will show section 2 and section 3. So this case study required a lot of thought-provoking questions of how to create new bents for the beams. After discussions, the team had decided to try and equally place the bents while avoiding major spacing between utilities, existing piles, and the MARTA CSX railroad tracks. So in the first section between MLK Junior Drive and the end of the first turn, our suggestion requires a bent to be placed there on the south side of the three existing columns. You can see that is bent 1 over here by the parking lot. Um, it'll be parallel in nature and will be very close to the columns due to that existing driveway that's on top of the bridge for that parking lot. The next bent will be placed around the existing brick building. Bent 2 can be shown here. Um, and the only intrusion that will be affected in this area will be the concrete ramp for the Georgia Freight Department, um, while that's under construction. But it shouldn't be closed for too long, so we think that this is okay. The next section, the next bent is in section 2, and that section went under review in the middle of the span because it covers from the first turn to the second turn. With this, we have to be more creative in the placement of the bents because of the utilities. Um, some lines can't be avoided due to them running into the length of the bridge, such as like the sewer. Um, and there's a section where that'll be less affected and is right between a set of existing columns and the Georgia State University sports arena. So the closer these piles are to the existing piles, the easier it is for rerouting different lanes, um, different utility lines, and diverting the traffic flow. The next pile our team suggested was located south of the intersection between the existing columns. That's here. And then this is the same bent 3 from above that's in section 2. Our fourth bent is at the very end of section 2. So that is located near the north intersection by the end of the span. And so by distributing the bents this way, we have less disturbance of the existing utility lines. To define where all the bents go, we can look at the box above the span that says LOS, which is a limitation for us. And the next bent is placed between the two major columns on the other side of Decatur Street in the beginning parts of section 3. And finally, our last bent 6, is also placed in between two columns towards the middle end of section 3. So in total, there are 6 bents, and this is in order to take on more loads, with each one requiring both higher strength concrete and more steel, which allows for more individual bents to take on more weight of the bridge. So now we're going to backtrack just a little bit to go back and see these purple boxes here are where our potential footing placements will be. Our team is also tasked with determining the potential footing locations. So we began by identifying the existing bents. Some of those are also highlighted in purple. And so we began by identifying those because the team wanted to avoid implementing new footings near the existing bents because they have existing piles underneath them. So we didn't want to interfere with those and the integrity of them. So the new locations for footings are shown in this purple color on both this section 1, section 2, and section 3 here. And so each of these are spread footings, and those spread footings are placed under every other existing column currently. So this allows us to place the footing somewhat evenly and avoid any of those existing underground utilities.
All right, so this ended up being the girden section that was chosen. As you can see, we chose a bulb tee that was 72 inches. Using the chart from lecture 3 is how we determined that we were going to use that 72-inch bulb tee. This is the best girder size for this project. We'll be using 150-foot spans for all the sections to keep all the spans the same length, and we'll maintain the same beam spacing for all of the spans, which will be 6-foot spacing. This is section 1. And this is a sketch of the elevation view of section 1 from MLK Drive to the railroad tracks. As you can see, this section is our longest section because it spans about 600 feet. Like I said, we're keeping that 150-foot span, and we have 7 columns spaced out at about 90 feet apart with 30 feet of overhang on either side.
So for section 2, this is a sketch of the elevation view of section 2 from the railroad tracks to Decatur Street. The section is approximately 450 feet. There will be 3 bulb T72s, 150-foot spans, 5 columns, spaced at 80 feet with a 25-foot overhang on either side. This is a sketch of the elevation view of section 3 from the railroad tracks to Decatur Street. The section is approximately 585 feet, and there will be 3 bulb T72s of 150-foot spans with a 135-foot span at the end. There will be 7 columns spaced at 90 feet with a 22.5-foot overhang on either side. And here are the lessons we learned. Bridge design has many considerations that must be taken into account, such as clearance, matching access points, existing utilities, just like what's existing already, like such as roads and all that. And there's not a one-size-fits-all approach to bridge design. All right. Thank you guys so much.